Introduction to AMPT, Assist Muscle Power Exoskeleton Device. This is a preliminary work in progress designed for an open-source 3D printable exoskeleton arm brace to assist the disabled to raise their arm. As someone with a form of muscular dystrophy called SMA, I have significant difficulty lifting my arms. Similar devices exist, but they are cost prohibitive for most people and are not covered by insurance. I wanted to create an open-source, inexpensive exoskeleton arm brace that utilizes both springs to offset arm weight and motor to raise the individual's arm that would be free to download and modify. Part of the concept is that this arm will allow additional snap attachments or modifications, and that it is easily adjustable for various body sizes. AMPT has undergone several iterations as I've tried simplifying the device and making it work for as many people as possible. This means that the device has to be easily modifiable and have the ability to attach multiple attachments depending on the need of the individual and their disability. The long-term goals of the AMPT exoskeleton device is to create a low-cost 3D printable exoskeleton, make it easily modifiable and upgradable to fit a variety of body sizes and types, to work by EMG muscle sensor board signal detector measuring module for an Arduino controller, to integrate artificial intelligence for a repetitive task, for example, detect motion involved with eating, drinking, or other tasks that are repetitively done. AMPT has undergone several design changes. Version 1 was less modifiable based on my own arm dimensions, and primarily used a pulley mechanism to lift the forearm. Version 2 experimented with several different alternate motor mechanisms to lift the arm. 1 was using the pulley, 2 was using a linear actuator, 3 was using artificial muscle, and 4 was using a direct motor. Each of these had their own advantages and disadvantages. Ultimately, I found that while the linear actuator was efficient, it was very expensive. The artificial muscle is still a little too experimental for use in this first version, but I may integrate that in a future version or add it to the existing design later on. The direct motor was the simplest, but it was the least powerful. You would need a very powerful motor in order to lift the arm, and the small hobby motors are not powerful enough to do this task. The pulley overall seemed to be the most efficient and simplest mechanism for lifting the arm. So I returned to the pulley mechanism for this iteration of the AMPT exoskeleton. Version 3 incorporates shoulder movement and after returning to the pulley mechanism. The shoulder movement is rather complicated because the arm can move in multiple directions, and it also requires lifting more weight. The next steps in the completion of the AMPT project require myself to become familiarized with the 3D printing process, including optimizing 3D print layout for distribution. Improvements are required to improve the motor lift mechanism to reduce the bulk and increase the torque. I must become familiarized with the Arduino programming and connection to an EMG muscle sensor board. Additional programming may include artificial intelligence to recognize repetitive tasks or repetitive arm movements. This may include connection to a smartphone via Bluetooth with categories of common movements such as motion required for eating, grooming, or other repetitive tasks. Finally, the must be done using minimal electronic sensors. I have to figure out how to allow one EMG motion muscle sensor, to control multiple motions of the arm, including the elbow-shoulder movements, both lateral and horizontal. This may mean having one muscle control several separate arm segments by identifying short pulses versus long pulse of a muscle movement. If you'd like to help in the development of this open-source exoskeleton, please contact me, Eric Ovagon, at darkrubymoonstore@gmail.com. That's darkrubymoonstore@gmail.com, or visit my website, darkrubymoon.com, for information on how to contact me. mechanical engineering, Arduino programming, robotic and data design suggestions, comments, or assistance would be most welcome. Thank you.